In this example problem, we are going to set up a regression equation to predict somebody's cell phone usage. To do so, we're going to make use of 4 different predictor variables. The person's income in thousands, whether they live in a rural area, binary, so yes or no, whether they're a college graduate, yes or no, and then we want an interaction variable. It's going to put extra emphasis on people who are college graduates and now live in a rural area, rural X college, if you will. And to find that, we'll find it just like we did in the previous example. You multiply your return for rural times your return for college graduate, or in our case, column D times column E for each respondent. In respondent 1, we'll have a 0 here because both things were 0. If I go and I double click the fill handle in the corner, it should fill in all of my numbers. And we check real fast to make sure everything's good. And yep, the only time that we get a 1 as a return is if the person said, yes, I live in a rural area, and yes, I am a college graduate. So now with that interaction variable filled in, I can go to the regression analysis tool under the data analysis pack. So I want regression, and I hit OK. And my Y range in this case is going to be the thing I'm predicting for, which in this case is cell phone usage in terms of minutes. So I'm going to grab everything in column B from B1 down to B81. My X inputs are going to be all 4 of my predictor variables, 1, 2, 3, 4, everything in column C through F. Control Shift down to grab the entirety of that, so my range should be C1 to F81. I have my label selected, so I want to make sure that check is on. And then for my output range, I'm just going to put this over here in column H19, right underneath where I need to put my inputs in. And I hit OK. And the returns that I get are as follows. We have our measures of goodness of fit, our adjusted R-square. We have all of our significance levels, but more importantly right now, since we're making a regression equation, we have our coefficients. And our intercept is going to be 14.92 and some change. Our coefficient for income is just under 1, so for every additional $1,000 somebody makes, our model is going to say that they use their phone for about an extra minute a day. Our inputs over here for rural is negative 42.32. So what we're saying here is someone who is in a rural area uses their cell phone for 42 minutes less a day than somebody who would be living in an urban area. Our model is going to say that college graduates use their phone for a little over 20 minutes a day more than people who didn't go to college. And then we've got our interaction variable. And our interaction variable actually has a huge slope. It's almost 50 minutes a day getting added into someone's predicted usage if they are both living in a rural area and were a college graduate. So I'm going to put that in as 49.8701. We have our regression equation. Is it, before we even mess around with anything else, is there joint significance? And that's this number right here in the ANOVA section, the F significance, if you will, which is a measure that of certainty that if you use all 4 of these variables instead of omitting one, you'll get a different return than you would if you omitted one. And that number is infinitely small. It is 1.09 in scientific notation to times 10 to the negative 22 power. Or in this case, we'll just say that it's 0. And since 0 is less than 5 right here, we definitely have joint significance. Yes. So our model as a whole is going to give us values in return that we couldn't get from each one of these individually. But real fast, and it's not part of the question, but I like to look anyway. What is the p-value that we have for our individual things over here? Ignore the intercept, which has a big number, because the intercept doesn't really represent the change of something. It's something you would have without the inputs of the other. What you are more concerned with in this case are your other predictor variables. And at 5% significance, that guy is near 0. He's less than 1. He's less than 1. Those are all incredibly significant. The only one that doesn't seem to be individually significant is college graduate. but it's necessary for this interaction variable that we have. So there's no way I'm taking this out of the model and just leaving rural times college by itself. So yes, we have joint significance. All our individual significance is close. This is the only one that's not individually significant, but I think it is still valuable to our model, and I don't want to get rid of it. So what I'm going to do here is I'm going to predict phone usage for somebody who has an income of 120 grand, who lives in a rural area, and who has graduated from college at this point in time. And all I'm going to do is fill in my regression equation up above. So take our constant of 14.92 minutes, add to it the product of our slope for our first predictor variable, and our first predictor variable was income in thousands. So we're predicting for somebody with 120,000, so I just put in 120. Please be careful not to type in the full 120,000 out, because we're measuring in thousands over here. You'll get a crazy high number. Somebody that never gets out their phone. Our second coefficient that we have is negative 42.3267, and that is for rural or not. Well, this person that we're testing for lives in a rural area, so I'm going to multiply that by 1. And for the third part of this, our third x value that we have, our predictor variable, the slope is 20.4745. We'll multiply that by whether or not this person, in our case, it satisfies the condition of our third variable, which is their college graduate. And it says here, yes, they graduated from college, so that's going to be a 1. And then we have our interaction variable, which has a slope of near 50, 49.87. And since this person got a 1 for living in a rural area and 1 for being a college graduate, they have to have a 1 for rural x college for our interaction variable. So with all of that thrown in here, I get a predicted usage, in this case, of 160.639. Somebody who meets this criteria, makes a pretty good living for themselves because they went to college and they now live in a rural area, is going to spend about 160 minutes or closing in on 3 hours a day on their phone, which is wild. But that's the number that our model is returning. Is our model an accurate predictor? Well, we're going to use the adjusted R squared, which I have down here, of just over 0.75, which is saying 3/4 of the variation that people can have in their phone usage come from these 4 inputs that we have. There's other factors, obviously, but this is capturing 75% of the possible variation. The other outside factors that could be in there are only going to make up 25% of the variation. So that is the answer that we've got to this mobile devices question. But looking at the situation, does this make sense to us? And I'm kind of thinking that it does. I mean, the more money that somebody earns, the nicer phone they're going to have, the more they're going to be on it. Most data packages nowadays are unlimited, but you still have to pay for that, and it's expensive. So somebody with higher earnings would have an easier time paying for unlimited data. And you're supposedly getting higher earnings from being a college graduate, so that could be true. Also, if you are a college graduate, you're much more likely to be working a desk job where it's very easy to get distracted on your phone when you should be answering emails, etc. So what about the rural condition? Well, being in a rural area decreases your cell phone usage. Does that make sense? Yeah, I guess kind of it could. Like, you get bad service in a rural area. It's really frustrating trying to watch YouTube when it takes 20 minutes for every video to load on your phone. Maybe if you're in a rural area as well, you're likely to work an outdoor job more, which is not as easy to be on your phone as it was if you're working a desk job in an urban area. But rural x college increases it. So what's really factoring in here is we're saying that someone that lives in a rural area that didn't go to college is less likely to be on their phone. But that is more than completely offset by the presence of someone going to college that lives in a rural area. So college, in this case, in our model, will be the thing that makes a bigger predictor of being a person that uses their phone a lot than being in a rural area.